In the same way that we had a notion of the well-being that consumers got from the trading at any situation, we're going to have a similar definition for firms, which is going to be called producer surplus, which is also going to tell us how much better off they are by being able to trade at whatever policy they are facing. So we're going to call the producer surplus PS at any situation theta just the profits that they get at theta. So this is the profits that they get at theta minus the profits that they get at no trade or no market. And notice that these are just equal to minus the fixed cost. If they don't trade, they produce nothing and they have to pay the fixed costs. Now, one small remark, you may find it puzzling that we are thinking of a measure of well-being of the firm and that is basically related to profits. But if this seems puzzling to you, as I have mentioned to you before, don't forget one important thing, that profits are income for firm owners. So when we do calculations about the impact of various policies in the market next time, we're going to have to keep track about what happens to profits, because that's going to affect the income of some consumers, in particular the consumers that are owners of firms. Now, the formula that we have just developed gives you a general formula that you can use to compute consumer surplus, provided you know the cost function so you can compute the profits. What I want to do for the next 2 slides is show you examples of how to apply this formula, and also to show you how it can be related to observed behavior in the form of the supply function. So look at particularly first at the case of free trading, which the firm decides how much to supply at price P. We know that the producer surplus at theta is going to be equal to P times Q star of P, that's the revenue, minus the cost of C star of P, that are just the profits at theta, minus the fixed cost, if any, which are the profits at no trade. We can rewrite this by expanding the cost as P, Q star of P, minus the fixed cost, plus the semi-fixed cost, plus the variable cost at Q, minus minus plus fixed cost, these two cancel, and we get this formula for the producer surplus, which basically is just giving us the profits at the situation theta, the allocation that it chooses at theta, ignoring the fixed cost. Why ignoring the fixed cost? Because there are constants that are the same whether or not the firm trades, so it doesn't really affect how much better off the firm is by being able to trade. Now, let's do a diagram to see how we can relate this to the supply function, and I'm going to draw this typical case that we have seen, in which for decreasing returns to scale, maybe with a semi-fixed cost, in which the supply function looks like this. Remember, there is a threshold there that is given by the minimum of the ATC SFC. We've seen this before. And this is the Q bar at which, when that price is reached, supply jumps, which is also equals to the minimum, the quantity at which the minimum ATC SFC is achieved. Now let's write down what the producer surplus is at any price P. It should be easy to see that when price is less than P bar, and we are down here, production is 0, and the profits are either 0 or minus the fixed cost, and therefore the producer surplus is 0. Now, what is interesting is what happens when we are in a price like this one, that is above, at which you are at an interior solution like this one. Well, let's derive what the producer surplus is in that case. It's going to be the revenue, which is just P times Q star of P, so this is the otherwise case, minus the cost. Now, the cost, we have to think carefully about how to compute them, given the information that we have. Now, we know that at that point, the average total cost curve is reaching its minimum, so we can compute the cost as producing the first Q bar units at that area. And that area is equal to minus basically P bar Q bar. But then we also need to take into account the cost of the additional production here, and this is just the area under the marginal cost curve. Remember that we know that this locus is also the marginal cost curve in that region. So we can write minus the integral from here to there, so from Q bar to Q star of P of C prime of Q dq. Now this can be equivalently rewritten, sometimes it's written like this, as P minus P bar times Q bar. So that is basically this much profits, that's that term, minus the integral from Q bar to Q star of P minus C prime of Q dq. Just to be precise, let me call this A, let me call this B. There is a typo there, it's a plus sign, and basically this area is A and the integral gives you that area B, and the producer surplus is given by that quasi trapezoid. Now I want to make two remarks that are very important. The first one is that this term appears whenever we have this semi-fixed cost that basically generate this jump. But we have also seen examples in which P bar and Q bar is 0, in which case this term is 0, and all that happens to compute the producer surplus is this integral. The second and more important remark is the following. We can define P star of Q as the inverse supply function, which is basically thinking of this locus as a function of Q, just inverting the function. And it's completely analogous of the inverse demand function. And notice then that this is going to be exactly equal to the marginal cost curve in this area from a firm that is maximizing at free trade. So we can also rewrite this as P minus P bar of Q bar plus the integral from Q bar to Q star of P minus P star of Q dq. And that is extremely useful because now the formula of producer surplus depends only on observables. P bar is observable, Q bar is observable, the amount demanded is observable, and the inverse demand function is observable if we have enough data. In other words, we can compute the producer surplus without any knowledge of the cost function. I hope the analogy with the case of the consumer is clear. Now look at the computation of the consumer surplus in the key policy that we saw before, which is a policy in which the firm has to pay a per unit tax tau, and of course it trades at P. Now let's think what the producer surplus is going to look in this case. Is going to be equal to P Q star of theta, that's the revenue, minus any semi-fixed cost that might be there, plus the variable cost of Q, minus tau Q star of Q. We saw before, Q star of P. We saw before that this tau can be thought of from the point of view of the firm as a shift in the cost function that is proportional to the price. Now suppose that you look at the data and you see a supply function that looks like this, say. So this is the supply function that you look when the tax is there. Now what do we know from before? We know that the threshold, because we know this because we have solved the maximization problem of a firm that faces this problem. We know that this threshold is the P bar plus tau, where remember this P bar is the minimum of the ATC SFC. We know that this jump takes place at Q bar, where Q bar is just the Q at which the minimum ATC SFC is achieved. We know that this curve this locus of points is equal to the marginal cost locus shifted up by tau. We saw that before. So we know all of that. Okay? Now the question is, at any market price P, what is the producer surplus? So let's think our way through this. We know, intuitively from the same reasons as before, and just from having solved the supply case for this case, that the price threshold is going to be this P bar plus tau. So when the price is below that, the firm produces zero. Profits are at most minus fixed cost, or zero if the fixed cost is at zero, and therefore the producer surplus is zero. That should be obvious. The question is what happens when you are in the other case, when you are above that. And let's take, for example, as before, a price that is here. Okay? Now, let's think our way through what is the producer surplus. It's going to be very similar to what we did for the case of free trade. Well, we know that the profits are going to be P times Q star of P, which is here. That's the revenue. And then we have to subtract the cost. And we can subtract the cost in two stages. First is this, for the same reason as before, and then is this area there. So that is going to be minus P bar plus tau Q bar minus the integral from Q bar, from there to Q star of P, of, importantly, the marginal cost function plus tau dq. Because remember, the marginal cost function here that is relevant has the addition of this tax. As before, we can rewrite this as P of P minus P bar plus tau times Q bar plus the integral from Q bar to Q star of P of P minus tau minus C prime of Q dq. And again, as before, just to be clear, we can think of this as A and B, and this term is A, and this term is B. So notice how the logic is very similar once we have the supply function, and we know that the supply is going to share the locus with the marginal cost plus tau. Now, question, can this be computed based only on observables? Let's think. This is observable, 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 this is not observable. But what do we know? We know that for a firm that is maximizing its profits when it fixes its per unit tax, this term is going to be equal to this locus. Let's call that P star with the T, the inverse demand function, given that there is a tax. So we can substitute that and become P minus the inverse demand function with the tax at Q, and that is observable. So as before, once we understand the logic of the maximization problem of the firm, given the economic constraints given by the tax, we can derive the formula of producer surplus based only on observables, which is quite a remarkable and nice property.